All right, so let's go ahead and get started. First of all, there's a couple of things we need to know in order to solve this stuff. Right? First, we need to remember all of this deals with Newton's second law. Right? So Newton's second law that I gave you in your notes was that acceleration is equal to the force of the object, or the force on the object divided by the mass. But remember, that force isn't any old force. That's the net force. Right? So that's the total force on the object. So you add up all the forces, all the positive forces, all the negative forces, and whatever's left, that's the net force. That's what you have to use in order to figure out the acceleration. Right? And we said that we didn't want to have to try and, draw pictures, all fancy pictures, because that takes too long. And some of y'all aren't great artists. Okay? Neither am I. And so we're going to use free body diagrams to help us out. It makes it a lot cleaner and a lot easier to figure out what the net force is. And so that's what this assignment was all about. This assignment was about being able to take a problem, do a free body diagram using the information in the problem, and then use the free body diagram to figure out the acceleration. Okay, so that's what the goal was. All right? But there's a couple of things that you needed to know, right? You got to figure out, you need to know how do you calculate weight. Right? And the notes that I gave you on weight were simple. That weight was equal to your mass, if you're calculating your weight, or the mass of whatever it is that you're weighing, times acceleration due to gravity, which we said was g. So that's 9.8. We're not really worrying about the negative or the positive right now. That's not important. So you can just take your mass and multiply it times 9.8, and that'll give you the weight of the object, or the weight of you. Okay? In this case, we're not talking about you, we're talking about the box. Okay? So on number 1, it says an applied force of 50 newtons is used to accelerate an object to the right across a frictional surface. The object encounters 10 newtons of friction. Use the diagram to determine the normal force, the net force, the mass, and the acceleration of the object. And then it says to neglect air resistance. The word neglect means to ignore it. It's not important. All right? So when we look at this thing, it said it was moving to the right. And so we know friction always opposes motion. So the friction is going to be to the left because the box is moving to the right, because that's what the problem said. So we're going to look at this and we're going to say, okay, so we have the force of friction, it's 10 newtons. Right? We also have the applied force, that's 50 newtons. Both of these are acting to the right and to the left. If our box is moving to the right, then what we're going to do is we're going to say to ourselves, self, how much force is left over? Because what I really have is I have somebody pushing this way, and I got somebody pushing back the other direction. And this person on the right that's pushing on it with 50 newtons of force, they're stronger than the person on the left. Right? The person on the left, or person on the right, is called friction. And the person on the right is applied. Stupid names, but it works. All right? So the applied is stronger than the force of friction, but by how much? What's the difference between the applied force and the force of friction in this case?
40.
It's 40, right? We got that by saying 50 minus this 10 comes out to 40. So now we know our force to the right is 40 newtons. But we also need to look at what's the up and down stuff going on. We need to figure out, is our box flying up in the air or is it falling through the ground? Now, is our box flying up into the air or falling into the ground? No, because it would say so in the problem. It said it was sliding across the surface. So what does that tell you about the up and down forces?
Well, they're the same.
They got to be the same. They got to cancel each other out. Because if the up force was stronger than the down force, then the box would move up. If the down force is stronger than the up force, then the box moves down. And so in order for the box not to go up nor down, both of them have to cancel out. So this tells me the force of gravity, which is weight, is 73 newtons. So how hard does the surface have to push up to keep the box from going down? 73 newtons. It's not a trick question. Okay? You need to recognize that these two things have to be the same in order for the box not to go crashing through the floor or launching off into space. All right? So if the up one cancels out the down one, then the only thing that you're left, the net force, the only thing that's left is 40 newtons. And it's to the right. So that means that my net force is 40 newtons. What questions do you all have? Yes, sir.
How are we going to get the mass?
Okay, how do you get the mass? Well, you come over here and you look at it and you say, okay, does it give us the mass up here?
No.
It doesn't, right?
Which total acceleration is 9.8.
Okay, so we know what the weight is, right? We know the weight, that's the force of gravity. That's 73 newtons. And I told you that weight is equal to mass times g. So I can rearrange this formula, and I can take the g and move it to the other side. And I do that through division. So now I have mass is equal to the weight, or the force of gravity, divided by g.
Oh, okay.
And that's how you get it. So, and g is 9.8. So I have mass is equal to the force of gravity, which is 73, divided by 9.8. What's that come out to?
7.4.
Comes out to what?
7.4.
7.4. And then what's the unit of mass? Kilograms. So now I have that formula up at top that says that the acceleration is the net force divided by the mass. I have the net force, it's 40. My mass is 7.4. So I have acceleration equals 40 newtons divided by 7.4 kilograms. And what did y'all get?
296.
40 divided by 7.4.
It's 5.4.
Say again?
5.4.
5.4? 5.4 meters per second squared. And that's basically how this game is played. I give you some information. You use the formulas that you know to figure out the missing stuff. If you look at these problems like a game, it'll be less horrible. All right. So let's look at number 2. Number 2 says an applied force of 20 newtons is used to accelerate the object to the right. So that means our box is moving to the right. Across a frictional surface, just like we had. The object encounters 8 newtons of friction. Use a diagram to determine normal force, net force, mass, and acceleration of the object. So it's similar but slightly different. Right? So what do we know the normal force has got to be in this problem?
The same thing as the G.
If the weight is 310 newtons, what's the normal force got to be? It's got to be the same, right? So what is that? 310 newtons. Right? So you know, since the weight is going down and the object's sliding to the right and not moving up or down, then those have got to be the same. All right. So what's the net force on my object? What's the total force? What's the total force in the up and down direction? It's 0, right? Because these two cancel each other out. So what's our force on the left and right direction? It's 12. Which direction? To the right. And that makes sense because our box is going to the right. So our net force is 12 newtons to the right. Does anybody need me to show you the math for that? Okay. So our net force is 12 newtons to the right. What's the mass of our object? Well, we're going to have to do the exact same thing we just did. So now we have mass is equal to the force of gravity divided by acceleration. That acceleration is g, because it's the acceleration of gravity.
310 divided by 9.8.
Yes, sir. 310 divided by 9.8, and that comes out to?
31.6.
31.6. And what's the unit? Kilograms.
31.6 divided by 12
Is?
is like 2.8.
Somebody give me the exact number, please.
0.379.
What?
Well, I used
Wait,
point.
isn't this supposed to be
I put 31.63.
The net force is 12.
It's 2.64, something like that.
This is 31.6, right? If we took 310 divided by 9.8. So now we're going to take 12 divided by 31.6. So acceleration is the force divided by the mass.
It's 3 point.
So the force is 12. The mass is 31.6.
Yeah, 2.6. 2.633.
I did.
No, it can't. You're doing the reverse.
It's .38.
You got to take the 12 and divide it by the 31.6.
Yeah, it's 0.379.
0.379? 379. Meters per second squared.
I did the opposite.
Yeah.
Okay.
Can you round it? Yeah, I mean, you could round it to 2 decimal places. Okay, we're not working at NASA, so that's good enough. All right. On number 3, you couldn't solve it the way that it was written. That's not your fault. That's my fault. Originally, we had taken these problems from something else where you had to calculate friction. So you're going to put this number here, 500 newtons. Now, if you were to be told that the force of friction was 500 newtons, then could you figure out the rest of it? And the answer is yeah. So that's what we're going to do now. We're going to work through this one. This one says an object is sliding to the right. It's encountering a frictional force that slows it down. Determine the force of gravity, the normal force, the force of friction, the net force, and the acceleration. Now all we do is we start out with 500 newtons. That's our force of friction. Does there have to be a force to the right? No, because our object's slowing down. Okay, so it's as if this thing is moving to the right, and then you got a little guy pushing on the box trying to slow it down. He's not strong enough to stop the box, but he is strong enough to slow that box down. So he doesn't need to have a lot of force. So we said that force was 500 newtons. Where did the 500 newtons come from? I just made it up. All right, now, it tells us that our mass of our object is 88 kilograms. Right? Now, if we have our mass of our object, can we determine the weight or the force of gravity on it? Yeah, we can. So that's the first thing we're going to do. We're going to say weight is equal to mass times g. So weight is equal to 88 kilograms. And that's times g, which is 9.8 meters per second squared. So somebody tell me, what is that number?
It's 862.4.
Say it louder.
862.4.
862.4. And that's, what is that? What's the unit of force? Newtons. Right? I could write that as F sub g is 862.4 newtons. All right? Because that's the force of gravity. So I'm going to write 862.4 newtons. Now, if my force going downwards is 862.4, but my object is sliding to the right, what does the normal force have to be? 862.4. Because this one has to cancel out the downwards force. And as long as your object is sliding across a horizontal surface, like every single last one of these problems is concerned, your weight and your normal force are going to cancel each other out always. If the object's going left or right, then there can't be any up and down force. So if there is a force, it has to get canceled out by another force. So here, we have the mass is 88 kilograms. The net force on this thing, well, what's my net force?
Or negative.
500.
It's 500. Because the up and down canceled each other out, so the only thing left is that 500 Newton force. So I'm going to write 500 newtons there. And then I'm going to calculate the acceleration. So acceleration
5.6.
is 500 over 88. And that comes out to 5.6 meters per second squared. What'd you get, Frank?
Oh, I accidentally put them in the wrong place.
Okay. No sweat. All right, let's turn this over real quick. Because the game basically doesn't change. It's always that. In number 4, it says free body diagrams for the 4 situations are shown below. The net force is known for each situation. However, the magnitudes of a few of the individual forces are not known. Analyze each situation individually and determine the magnitude of the unknown forces. So what you're just trying to do is figure out what force is missing so that you can come up with our net force. So in number 10, it says the net force is 0. Right? So if my net force is 0, what does that tell me all the forces have to do? They all got to cancel each other out. So if I have 150 Newton force down, what do I know has got to go up? 150 newtons. Don't make it hard. It's not. If you got 37 newtons to the right, what do you got to have to the left? 37 newtons. Don't make it hard. It's not. Number 11. We have a 900 Newton force total going up. That's what the net force says. It says it's 900 newtons total going up. If I have 180 newtons going down, what force would I have to add to the 180 to get 900? Well, let's actually write out an equation just because I'm that way. Right? So I'm going to have the force up minus the force down has got to be equal to the net force. So that means my force up is going to be my force net plus my force down. Mathematically, that's how I do that. So if my force up is 900 and my force down is 180, what's my total force got to be? It's got to be 1,080. I'm sorry, scratch that. Yeah, no, 1,080. Because if I do the force up equals 900 plus 180, 900 plus 180 comes out to 1,080 newtons.
Yeah, but if it isn't it 900 going up,
Right.
the top number has to be like really big. That if it's minus 180, it's going to equal that.
Right. So if I take this top number of 180 and I subtract 180 from it, then I get 900. Okay? So you don't have to necessarily come up with a formula. Okay? You can just look at it and reason through it. But be careful when you're reasoning through it. Okay? So let's look at 12. Number 12 says you got 55 newtons to the left. Right? So what does that tell you about the up and down?
They have to cancel out.
They got to cancel out. Right? So if I got 300 up, what do I got to have down? 300. Right? So now I got 55 to the left. Right? But I pushed with 140 newtons. So some number took away enough force so that now I'm only left with 55. So how would I do that mathematically? How would I get the right number?
140 minus 55.
Yeah, you do 140 minus 55. that'll give you how much it takes away. So what does 140 minus 55 come out to? 85. And you can check that. You could take 140 minus 85, and you better get 55. And in fact, you will. What questions do you all have? Does this make more sense now?
Yeah.
All right. So you're going to work on this, and you're going to finish this problem set up. And then you're going to turn it in, and you're going to grade for it. Work together, okay? If you don't understand what's going on, ask the person next to you. And if neither one of you understand, then ask me. Yes. And if you didn't get a copy, then let me know, and I'll get you a copy. All right, go ahead and start.